get started. My name is Yiming Chen, and I'm from Origin Lab Technical Support team. Today, I'm going to give an introduction to the time series graphing and analysis in Origin. So just to let you know that these features I'm going to talk about today are mostly introduced in the latest version of Origin. So please feel free to give it a try in the Origin 2024B. Okay, let's get started. Okay. During the webinar, if you have any questions, please post it on the Q&A window. And the recording of this webinar will be posted on our website early next week. Okay, so let's first take a look at what a time series is. So time series data is a sequence of data points, typically measured at successive times and spaced at uniform time intervals. And the questions that are addressed by time series analysis, the first thing is we can figure out the pattern of the data and to try to figure out the trend and the seasonality from the time series. Of course, with the time series, we're going to do a modeling and we can do a forecasting for the outcome for the future. And we can also do the causal relationships. So basically, if you have two time series data, you may want to know whether they are correlated and by what lags, which number of lags in the time. Okay, and another very important area of time series analysis is the quality control and anomaly detection. And just to know that we have a statistical process control app. Let me just quickly show you the app page. This is another very important aspect of the time series. It's widely used in the industry. Also, feel free to give it a try. And also, we have webinars on the how to handle the date time data in Origin, like how the daytime value is stored in the Origin, and how you can manually change the datetime values in the worksheet. Let's see. Let's date. Okay. Just so you know, you can find the webinar, early webinars on our website. Just feel free to take a look. And also we have web pages discussing the daytime in Origin. Okay. Let's just go through each topics I listed here. So usually when you have a time series data, you have like two columns, the time data and the measurements. And before you do any time series analysis, you need to make sure the time values are evenly spaced. So in Origin, if you just simply click on the column header and show the spark line, you can tell whether the time values are evenly spaced. But look at this data. If the time values are not evenly spaced, we need to convert or do the resampling of the data in the evenly spaced time interval. So in Origin, one option is to do interpolation. Let's say if I just simply click column B and go to the analysis mathematics, and there are a couple of interpolation tools in Origin, but we can use this one, interpolate, extrapolate. The dialog. Here basically you can specify the method of interpolation and the number of points, or you can specify the time intervals. Okay, and for the output, let me just choose new XY, and you can turn on the auto preview to check the interpreted data as sort of like overlapping with the original data. And if I click OK. Now just if you turn on the spark line, you can tell the time values are evenly spaced now. Okay, so just this feature. This is not a new; it's an old feature in Origin that like some preparation for your data before the analysis. Okay, next let's try to check some of the time series plot in Origin. First of all, let's say I have this time series data. The column A is it's a daily data, and the column B is the measurements. And we introduced this graph template called time series explorer template. Most of the template are if you want to make a graph from a worksheet, basically you just go to the plot menu and choose a template here, right? And this new template is introduced as extended template. So for extended template, they are not pre-delivered with the Origin software, but you can go to the template center here, okay, to download the template. So it's called the Time Series Explorer. Okay, I've already downloaded it. Okay, then I can just highlight column B and go to plot menu and go to the extended templates category and find this Time Series Explorer template. Okay, basically it plots the entire time series in the lower panel, and there's a ROI box is on top of the um, layer, and you can just drag it to just examine the a portion of your data. Then the time the data within the time span will be plotted on the top panel. And you can also click this button, say I want to check the annual data, and you can click the left and the right to move the ROI left and right. And yeah, you can specify quarter data. And you can also click this play button to, yeah, and you specify a time, like I want to make the move of the ROI every 1 second, and it's click OK. Yeah, I just move the ROI to the right, and you can see how the uh, data changes with different time. Okay. So yeah, so you can check this graph template. It's called a Time Series Explorer. Let me close this. Another time series plot is coming from this app called the Time Series Analysis. So again, this app is introduced in the latest version of Origin 2024B, and you need to have the latest version of Origin. Okay. So if I just click on this app, yeah, okay. So for those who have not used the app in Origin, just to know that you can come to this Add Apps and click that and to turn on the App Center dialog, and you can do a search for time series. Okay, if you found the app, you can click the download button, and the app icon will be shown on the apps panel. Okay, so let's start with just by clicking on the. It has many tools within this app. So this is so I will start with the time series plot. Okay, you can plot the time series with a single curve or with multiple curves grouped by the categorical column. Okay, let's start with a simple. Basically, it shows a preview on the right-hand side, and you can apply a smooth. Yeah, the local weighted linear regression smooth will be applied on the data. Okay, you can specify a smooth window size. Larger value gives you more smooth on the data, and you can apply a group here as well. So basically, I have this 3 columns of data. So the column C contains the value of the year. Let's say I want to color the time series by year value. I can choose year here. Yes, then it shows a preview on the right. And if you click OK, yeah, it will gives you this graph. Okay, yeah, you can quickly do some customization. Maybe yeah, if I want to start I know the date value start from year 2004, January 1st. Okay, and I click apply. Then for the tick increment, I want to let's say by 1/4 if you want. Okay, and you can apply a grid line to the graph. Yeah. So this way you can quickly check your time series values, whether they have like if there's some seasonality, whether the data is periodic, or does it has some trend going up, the direction is going up or going down. If you can remove the noise by just uncheck the origin, the graph, the group one, so that you just hide the original data and only see the smooth the values. So this way you can quickly tell the trend and the seasonality of the data. Okay, give you a quick view of your data. And if you want to add more smoothing to the data, you can click the green lock. Yeah, you already know that you can bring up the dialog by clicking the green lock and do change parameters. Let's say I want to increase the value. Oh, that may be too much. Okay, and click OK. Maybe just okay. Yeah, so yeah, you simply apply more smooth to the data, and yeah, you can check the pattern. Okay, so this is a time series plot. Let me go to the next topic. So here I'm gonna talk about the unstack time data by interval. So this is a new tool introduced in Origin 2024B. Let's say I have this data, and you can quickly tell it's like a daily measurements of the sea level. I want to, unstack the data by the time. Maybe I want to the annual yearly data to be saved into different columns. Let's say if I just highlight column B and go to the menu restructure and find this unstack by time interval. Okay. So first of all, you select a time interval. I want to divide the data by year, and you can show the data from the time series of the whole year, or you can just choose a time span for each year. Let's say I want to just check the data from the July to the end of the year. Okay. Yeah, and we'll talk about the rest in a few moment in a moment. Let's click OK. Yeah, so it generates the data set and for each year, and the start and the end date for each year. Okay. And let's say if I simply select all the columns and I make a plot to examine the data. Okay, I can go to the plot menu and find this browser graph. This graph template has been in Origin for a while, and it lists all the columns in the worksheet in the left-hand side, and basically by default it shows the column short name, and you can right click and say I want to show the year. Okay, and then you can select years to check the time series from different year. And for example, if I want to compare multiple years data, I just need to select multiple columns or years from the left panel. And you can also, let's say, if I click the button here and say I want to select every nth, so I want to compare like maybe 20 years, let's say. Okay. If I click OK, so it will so the 20 years apart will be selected in the left panel, and I can quickly check, and I can like go do like a flip through. Okay, I want to move them by 1 year at a time. Okay. Okay. Yeah, another thing I want to mention is I can change the legend. Okay. Instead of showing sea level, I can show the year. And I can also move the legend to the curve, let's say, attached to plot. Okay. Yeah, I don't need it anymore. This way I can flip through, and you can also check the year value on the graph. Okay. So this is one data set. Let me quickly show you another data set. So this is the okay. So for each day it has multiple measurements at different time. Okay. So in this case, I will need to use a customized format. Copies. Control C to copy, and let me quickly go to restructure, unstepped by time series interval. So for the time interval, let's say this time I was choose day, and I was for the additional label row, I will just paste the customized format. So it will show additional 3 column label rows: weekday, month, and a day. Let's see how it works. Okay, so it's just put the day value, weekday, and a month. Okay, the month, you don't see that is because they are merged. Yeah, so you see that the same month are merged together, the cells. Okay. Again, you can use that to make a plot. Yeah, I just use the recently selected plot. Okay. And you can right click and say, I want to show the day value and show the weekday. So if you want to check the time series for all Mondays, you can, as I showed you before, that you can choose select every nth, let's say 7. So every 7 days will be selected. So all Mondays are selected, and you can do a flip through and to check the values from all Tuesdays or Wednesdays and etc. Okay. So this is a nice tool that you can quickly tell whether there is a similarities between the time series from different time span. Okay. Okay, let's go to the modeling of time series. Okay, so yeah, so basically, which model to be used to analyze data, is depended on how the data itself looks like. Before do any modeling, we need to tell whether the data itself contains some feature for trend or for certain seasonality. Okay, so if I in Origin, basically you have this sparkline feature. If you turn on the sparkline for the column, you can basically tell the pattern of the data. Okay, so the first of all, let's say I will look at this data with no, with no trend and seasonality. Okay, in this case, we can use a simple model called a moving average. First of all, so basically you predict the observation at current time stamp by the average of its history of the observation within a certain time span, and where the time span is determined by the size n here. Okay, so if you do that, if you want to do a moving average, we need to use the time series analysis app here. Just click that, go to the smooth, and then moving average. Yeah, so this is a simple model. We will start from the simple to more complicated models. Okay. Yeah, basically you just specify a moving average window size. Okay. And yeah, you want to put the average value at the current value, or it's on the for the prediction. Yeah, things like that. And if you want to do a forecasting, you can check this box and tell how many time stamp ahead you wanted to forecast. Okay. Yeah, and other things is some statistics and the plots that you can choose from. Okay. Click OK. Yeah, basically, one important statistics is the mean absolute percent error. It tells you how off the prediction from the original data. Okay. Let's say if I can just quickly view the actual data, the fitting, and also the forecast. Okay, and you can also check the residue. If it's a good fitting, the residue should be normally distributed, and you should see a normal distribution, uh, normal distribution curve, um, sort of like that, and you can tell whether it's normally distributed by the probability plot. Let's quickly check. And one thing just want to mention is that you can use this graph to check the outlier. Let's say you want to check, well, we see like two outliers here. Basically, in Origin, you can use the data highlighter tool to just choose these 2 points. Okay. Then it also highlights the outliers on the original data. You can tell at which time there's maybe some abnormal data points you want to check. Okay. So this is a moving average, and it's also it's the simplest model. And a more complicated model is called a single exponential smoothing model. So what's difference to the moving average model is that it applies a exponentially decay weight to each historical observation to predict the current um, observation. Um, Basically, all the historical y values are involved in the model, but um, just a higher weight is put to the more recent observation. And yeah, if you use another like a more like dynamic model format, you can assume there is a level component in the time series, and you just uh, predict the current y value by the level component for the one timestamp uh, behind. Okay, and the level component is also a weighted average of the current observation and the state level value from the past. Okay, and one parameter you need to specify in the dialog is the weight value alpha here. Okay, so this is just basically you use this model to estimate the parameter alpha. Okay, let's go back to the data and let's start the tool here. It's under the smooth and the single exponential smoothing. Yeah, that's why it get the name single exponential, because here is only one parameter need to be fit. Okay, let's say here for the time series data, I can select column B in the dialog. Yeah, you can let the origin to calculate the smoothing constant or the alpha value automatically, but sometimes it doesn't give you a correct value, but you need to specify value between 1 and 0 and 1. Okay, and um, and you can specify value the forecast numbers here, and yeah, because you are using the historical data for the prediction or for the model for the modeling. So the first couple of data points are the first data points is not involved in the modeling. So you need to initialize the first the prediction of the first data point. Okay. Here, let's say I can, yeah, if you increase the number, if you increase the number of the alpha, you just apply more smoothing. Let's see. Okay, sorry. If you increase the value of the alpha, you just give more weight to the historical value. So it's give you less smoothing. And if you apply 0.1, give it a smaller value, it just apply more smoothing to the value to the data time series. Okay, let's click OK. Again, you can check um, the percentage percentage of the mean absolute error. Okay, so it's off by 6%, not that bad. And yeah, you can check the smooth plot and the predict plot. Okay, and here the alpha that you choose is 0.1. Okay. Okay, so this is for the data time series with no channel and the seasonality. A more, let's see another data set. So this time the data, yeah, obviously this data set has some upward direction. So it has some trend. There are again two models that you can choose to model such kind of data. It Yeah, so if the trend is very consistent, you can model the trend with a fitting function, then you can use this trend analysis tool. If the trend is more dynamic and going up and down, for example, you can use a double exponential smoothing. We will check both of the two. Let's start with the trend analysis. I can select a column and start a tool, trend analysis. So to use this tool, you need to specify a model type. So let's say which fitting function you want to apply to the time series. Okay, so linear, quadratic, exponential, or logistic. Let's just do a quadratic. And you can also specify a number of forecasts for the model. Yeah, it's nothing special. It's just to use a fitting function to fit the data. Okay. Yeah, so because this have very obvious or strong trend, so it's you can tell this MAPE value is very small, and it gives you the fitted parameters and the fitting functions is also shown here, and yeah, the residue doesn't look very normally distributed. Okay. Uh, Another model we can use is called the double exponential smoothing. So in this case, the predicted y value is the sum of the level component and the trend component. Yeah, and you can tell you can see here the level and the trend component are calculated by the weighted average of the previous um, observation value and also the other term. Okay, so here in this case, we need to uh, estimate two parameters, alpha and gamma. So this is called why it's called a double exponential smoothing. Okay, so yeah, just so you know, this the predicted value has two components when during the fitting. Okay, let's just quickly do the uh, fitting. Let's go to the time series analysis. So this time we will use I think it's on the smooth double exponential smoothing. Okay, so here, let's say go to the settings. Yeah, if you choose the optimal ARIMA, so it will, yeah, so I'll talk about ARIMA in a moment. So it will use the ARIMA model to, I think it's using the 011 model to fit the data first and determine the alpha and the gamma value. Or otherwise, you can specify the 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 gamma and the alpha by yourself. Okay. Yeah, again, you can choose 20 forecast you want to do. Yeah, the rest are the similar. Let's click OK to check the result. And the MAPE value is 3% off. And they calculate the calculated level, fitted level and the trend values shown here. And again, you can check the fitted, the green dots are the fitted values of the time series and also the prediction. And it shows higher error for the time more in the future. Okay, so this is the time series with trend but no seasonality. Okay, let's see a more complicated data set. So this time I have a seasonality. Okay, so if you just check the data and one thing you may want to know is the number of seasons in the data set. So if the one quick way to do so is you can double click on the spark line to just uh, bring up the graph. And if you just hover your mouse over the data point, let's say the number of seasons is basically the distance between the peaks. Okay, so it tells me this is the row 8 and row 19. It's roughly about 12. So since it's the monthly data, we can tell that the seasonality or the number of seasons is 8 or is 12 in this case. Okay, so let's see. Again, I have two models to for this time series with seasonality. We can use a decomposition tool, or you can use a Winters method. Um, First of all, we need to know that whether we will use a additive model or a multiplicative model. So for additive model, it's just the sum of the seasonality, the trend, and the residues. And in the other hand, the other model is the multiplication of the three terms. Um, to determine which model to use, we can just check this the pattern of the data. If the amplitude of the seasonality varies with the trend, so for example, in this case, when the trend goes up, the amplitude of the seasonality is also going up. So in that case, we will use the multiplicative model. Okay. And another thing I want to mention is for the decomposition tool in this app, we assume that the time series follow a linear trend. Okay, so in this case, if the data set itself has more complicated trend or dynamic trend, we will use the Winters method instead. Okay, let's start by checking the tool. So it's under transform and decompose category and use the decomposition. Okay. Let's say the time series, I will choose column B. Yeah, since we have the time label for column A, I can choose column A as time label. For the settings, yeah, as I said, as we have determined that the seasonal length is 12. Okay, and for the model type, I will choose a multiplicative. Yeah, if you click the additive, you see the fitting is not quite well, right? So, and model components, yeah. So of course, this data has a trend. Okay, and I can forecast for 2 cycles, so it's 24 points. Okay. Yeah, and also other statistics and plots. Okay, just click OK. And for the decomposition tool here, other than the statistics and the plot with the original data and the forecast, it contains more results. Okay, so this is a component analysis. If you just bring up the graph, it shows the original data, and the original data corrected by the trend. So the trend is removed from the original data, and the original data corrected by the seasonality. So the seasonal component are removed, and also corrected by the trend and the seasonality. So basically, ideally, this has to be normally distributed, like a random noise. Okay. It also gives you this seasonal analysis plot. It basically shows the variation of the data for each month in this case. Okay, and also the residues of the plot of the residue as a box chart for each month. Okay, so you can see the seasonal factors upon the data set by looking at this graph. Okay. Yeah, so this is the decomposition. Okay, as I said, if the data set has a more dynamic trend. And if you want to use this model for forecasting, so a more strong model is called the Winter's method. So it's similar to the double exponential method I just talked about a moment ago. So other than the the level and the trend component, there are third component, seasonal component, will be included in the model. And for the additive and the multiplicative models, you can see it's quite complicated, but just you know the fitted y value is the sum of the level, trend, and the seasonality for the additive model, and it's the sum of the level and the trend multiplied by the seasonality for the multiplicative model. Okay. Okay, let's just quickly check the Winter's model being applied on our data. Okay, so it's under the smooth Winter's method. Okay, and choose the time label. Seasonality is 12. We'll use a multiplicative, and here you can adjust the three parameters. Okay. Yeah, it's you can tell by you can tell the which parameters to use by looking at the preview of the fitted curve on the graph. Okay. Yeah, I can still just do a prediction for 2 cycles ahead. Okay. Yeah. So yeah, basically this gives you the result. Okay. Yeah. Again, before doing any modeling, make sure you understand the data well, whether it has what kind of trend it has, what kind of seasonality it has. Okay. Let's go to the next topic is the ARIMA model. So, okay, so here I have this data for the quarterly US consumption expenditure. And for a non-seasonal ARIMA model, usually it has three values for the order. So it's similar to like a polynomial fitting. So before it's fitting, you have to determine the order of the polynomial. So in this case, I have three orders. So the P is the order for the autoregressive part, ARP, we call that. And the D is the degree of first differencing involved. So whether you want to do a differencing, so you sort of like calculate a new time series by do a differencing on your original data. Okay, and the third is the Q, the order of the moving average. So we call the moving average Q. So basically, this is the example like ARIMA 112. Y if the second is D, so you need to do one order of differencing. So the YT prime is the YT minus YT minus 1. So then you use the YT prime for to build the model. And one order of the autoregressive means you have one term of the historical observation. So you have one term for the autoregressive model, and two moving average. You have two terms of the historical errors in the model. Okay, basically it's you determine the number of parameters by telling the order of the ARIMA model first. Okay, then so before we need to use the stationary test and the ACF and the PACF determine the order of the model. Okay, so let's start by doing a stationary test. Let's again highlight the column and go to the and this time I will go to statistics and testing and find the stationary test. Okay. I assume there is a constant in this data. Okay, so I don't care about the trend. I assume there's no trend. Let's say click OK, and it gives me the conclusion that at 0.05 level the time series is stationary. So that's good. So I don't have to do the differencing. If it has some trend or the stationary test failed, then we need to do a difference. Okay, so then we now know that the d value is 0 in this case, and then I want make a ACF and PACF plot. Okay, again, go to this tool and find the let's see, it's under the okay, so ACF and PACF plot. Okay, yeah, just to make sure the PACF partial correlation plot is checked, and click OK. Yeah, yeah, I'm not gonna talk too much about the theory, but basically, if you see the autocorrelation plot is exponentially decay and going up, and above or below the 0 axis, and if you check the PACF plot, it just shows spikes at the first couple of timestamp. Then it has a AR order. So, for example, here I have 3 spikes at the beginning. So the AR it's AR3 model, and the autocorrelation plot is exponential decay. Okay, in this case, we can determine that the p-value or the order of the AR model is 3 and the Q value is 0. Okay. Now, in this case, I have determined all 3 orders. Then I can use these 3 orders for the modeling. Okay, let's go back to the data and go to the ARIMA model and click ARIMA. For the modeling here, so autoregressive is 3. That I don't have difference, so it's 0. And I don't have the seasonality, so just uncheck this box. Okay. Yeah, so the rest are the similar, and click OK. Yeah, it will run the model. Yeah, you can quickly tell from the p-value of the 3 parameters. So they all below 0.05. So the model is good, and the 3 parameters are significant different from 0. Okay. So this is the non-seasonality, non-seasonal data. Let's check another data with a seasonality. So in this case, yeah, so this is like a monthly data. And yeah, again, by quickly just to check the peaks, we can tell the number of seasons is 12. So of course it's a monthly data. Then we want to do a stationary test. Because data has this kind of a seasonality, it doesn't satisfy the requirement for the stationary. So to do that, so before that, we will do a seasonal differencing. Okay, let's just start the tool, and we can do a difference. Okay. So for the differencing order, we will choose 12. Okay. Yeah, you can tell from the preview graph that the seasonality has been removed. Okay. Yeah, let's just click OK. Then we will do a stationary test. Okay. Again, go to time series and stationary stationary test. Okay, so time label, I don't have to do that. Yeah, just use the default settings. Again, we assume there's a constant constants in the model. Okay, click OK. Okay, so it tells me that at 0.05 level, the time series is stationary. Okay, so which tells me I don't need to do a difference of data, but I need to do the seasonal differencing on the original data. Okay, now let's use the difference data to plot ACF and PACF. Okay, again, let's go to the ACF and PACF. Yeah, just use the default settings. Okay. Let's see. Partial correlation. Okay. Yeah, ACF doesn't give me much information, but sorry. Okay, so for the PACF, we can tell that the first three dots are beyond the limit. Okay, let's see. Let's quickly check the settings. Okay, it should maybe I should use the original data for the ACF. Okay, sorry, I have to use this original data for the ACF and PACF. Let's do it again. So station ACF and the PACF. Okay, still not very correct. Okay, anyway, I'll go back and check, but just so you know that you will use these two graphs to tell the order of the model. So the here the P is 3 and the seasonal P value is 2, and I will use this order values for the modeling. Okay, let's go back to the original data and use the ARIMA model. In this case, I will go to the model. So I have the seasonal component in this case. Okay, let me just quickly. So the autoregression is 3, and the period is 12, and the autoregression 2 difference is 1. Okay, and I can use that model for the fitting. Okay, make sure you just forecast 2 cycles, which is 24 points ahead. Okay. Yeah, again, you can quickly check the p-value of its parameters in the model. Okay, and check the original data and the predicted point. Okay. Okay, there's some time. I'll quickly talk about cross correlation. Assume that I have 2 time series. I want to check whether they are linear correlated with each other and by how many lags they are correlated. We can use this cross, let's see, it's under the statistics test, cross correlation, okay? Choose column B and the column C. And yeah, by looking at the graph, we can see the spike here, okay? Yeah, if I click OK. Yeah, so like at lag of 2, they are strongly correlated. Okay, but sometimes if we look at another 2 time series, okay, let's try the 2 again. If I use these 2 time series, you see the spikes almost for all lags, which means there's something wrong with the data itself. This is because in order to do a cross correlation test, we need to make sure the data itself is like there's no autocorrelation. We need to remove the autocorrelation from both time series because this data is not real data. I simulated it with the ARIMA 110 model. So there's a one order of autocorrelation or autoregressive here. So we need to remove that autoregressive from the model. In order to do that, we have this tool called pre-Witten. It's on the ARIMA pre-Witten. Okay, let's use that and choose the column B and the column C. Okay, and because I know it's a ARIMA 110 model, so I just put 110 here and click OK. It will remove the autoregressive from each spectrum. Okay, then I just go to the data here. I need to remove the missing value. Okay, let's delete it. Okay, now let's do a cross correlation plot. Let's go to the time series and cross correlation. Yeah, then it shows a strong spike here. Okay. Yeah, so for the data, if we're not sure whether they have autoregressive in the data set, you need to use a pre-Witten tool first. Okay, so now it shows a strong correlation with lag 3 and lag 4. Okay. Okay. And I will quickly, because in the time series analysis app, we have another spectrum analysis category. Okay, so it's called the univariate spectrum density with Daniel method, and also another different method called the lag window. I will just quickly talk what it does. So if you have a signal or like a time series data with a strong periodic feature, you may check the data in the frequency domain. In order to do that, use FFT or fast Fourier transform. We have this tool under the analysis signal processing and FFT. Okay, yeah, we have a bunch of signal processing tools in Origin. You can use FFT to do to obtain the sample spectrum, which is like the power as a function of frequency. So it's a not different presentation of the data in the instead of in the time domain, it's in the frequency domain. In Origin, we have in this app the tool here. Okay, so the first tool here is just to a sort of like a Fourier transformation on the data from time domain to the frequency domain, but apply some smoothing. So there are one smoothing method is called Daniel method. Yeah, so you see the sample spectrum is more smoothed, and it's the another tool is using the lag window smoothing method. Okay, so basically these are two like a Fourier transform method by applying the smooth. Okay, so I'm not gonna talk too much about that, but just you know that for every tool in the app, you can click the question mark here, and it will open this help page. Okay, it contains a tutorial on how to run the analysis on your data, and it also contains the algorithm. Okay, on the bottom it has this reference, so you can if click that, it will open up the neg library, the function that we use to apply the tool. So it gives you very detailed explanation of what its parameter is. For example, here you need to specify a taper method, and you want specify a smoothing window and what the shape ratio of a trapezium means. Okay, you can get all the details in that help page. Okay. So this is basically the things I want to cover in the time series analysis. Yeah, again, this is a new feature introduced in Origin 2024b. Just feel free to download and try these tools. And if you have more questions, feel free to send us tickets. And also the recording of this webinar will be posted on our website early next week. Okay, thank you for your time to attending this webinar, and have a good rest of your day.